Suppose you are given this messy electrical circuit with a battery here and a bunch of resistors connected in what looks like a confusing web of series and parallel connections. Then someone comes and says, "Hey, I want to measure the voltage and current at each resistor, like say if I connect a voltmeter, which measures the voltage across 2 points, at this 15 ohm resistor. I want to know the value of the voltage that it will show. Similarly, if I connect an ammeter, which measures the current across 2 points, beside this 8 ohm resistor, then what will be the value of current that it will show?" Before we begin, let me give you a quick revision about voltage, resistors, and current, such that using only these basic concepts, you can confidently tackle even the most complex-looking circuit step by step. You will never need anything else. If we have a resistor and a current flows through it in this direction, then the resistor acts like a voltage eater. It munches on some of the energy from the battery, and this is called a voltage drop across the resistor. The voltage drops in the direction of the flow of the current. So, if the current goes left to right, the left side of the resistor is at a higher voltage, and the right side is at a lower voltage. The amount of voltage it will eat depends on the value of the resistor and the current flowing through it, and is given by V equals I times R. For example, if a 2 ampere current flows through a 5 ohms resistor, it will eat 5 times 2 or 10 volts. This means if the left side of the resistor has 12 volts, then the right side of the resistor after the drop will have 12 minus 10, or 2 volts. Also, if there is no resistor, then there will be no one to take the commission, and hence there will be no voltage drop. So, if this is 12 volts, then this will also be at 12 volts. Next thing to note is how resistors behave when they are connected in series and parallel. When resistors are in series, they are connected one after another, so the same current flows through each resistor without splitting. The total resistance in a series connection is found by simply adding up the resistance values of all the resistors. For example, if you have a battery of 30 volts and 3 resistors with resistance values of 3 ohms, 5 ohms, and 7 ohms connected in series across this voltage like this, then the total resistance would simply be 3 plus 5 plus 7, which equals 15 ohms. This means the circuit behaves like a single resistor of 15 ohms. The current can be found by dividing the total voltage by the total resistance, so 30 volts divided by 15 ohms, which equals 2 amps. Now this same current will flow through all these 3 resistors, so each resistor will have a voltage drop equal to the current multiplied by its resistance. This means the first resistor has a voltage drop of 2 amps times 3 ohms, which is 6 volts. The second resistor's voltage drop is 2 amps times 5 ohms, which is 10 volts. The third resistor's voltage drop is 2 amps times 7 ohms, which is 14 volts. So at this left side of 3 ohms we have 30 volts, and right side will have 30 minus 6, or 24 volts. Then, at the left side of the 5 ohms resistor, the voltage is 24 volts. And after it drops by 10 volts, the right side will have 24 minus 10, or 14 volts. Finally, at the left side of the 7 ohms resistor, the voltage is 14 volts, and after it drops by 14 volts, the right side will have 14 minus 14, or 0 volts. Next thing to note is how resistors behave when they are connected in parallel, where all the resistors are connected across the same 2 points, which means the left and right side of the resistors are connected to the same 2 points, and thus they will have the same voltage across them. However, the current splits up and flows through each resistor separately, depending on its resistance. Unlike series, the total resistance in parallel is found by using this formula. For example, if you have 3 resistors with resistance values of 2 ohms, 3 ohms, and 6 ohms connected in parallel, and a battery of 12 volts like this, then 1 over equivalent resistance R equals 1 over 3 plus 1 over 2 plus 1 over 6. This gives R equals 1 ohm. So what will be the value of this current? It will be 12 over 1, or 12 amperes. So now the main question is, how much current flows through each resistor? The voltage across each resistor is the same because they are connected in parallel, and that voltage is 12 volts. This means for this resistor, the voltage drop is 12 volts, and resistor value of 2 ohms. Therefore, current equals 12 divided by 2, which is 6 amperes. Similarly, for the 3 ohms resistor, current equals 12 divided by 3 or 4 amperes, and for the 6 ohms resistor, current equals 12 volts divided by 6 ohms, which is 2 amperes. If you add these currents together, 6 plus 4 plus 2, you get 12 amperes, which matches the total current flowing from the battery. This shows how the total current splits among the resistors in parallel, depending on their resistance. With this theory, you can now solve any complex circuit by breaking it down into simpler series and parallel parts. So, for our original question, the very first thing you should do is label all the points. Let us label this as A. Then this point will have different voltage because of this resistor, which will drop the voltage of point A. So label this as B. Similarly, label this as C, then this as D, this as E. But wait, we don't have any resistor here, and thus there will be no voltage drop, which means both these points are the same. So keep it D only, and finally this as E. After that, across the battery label, the voltage value as 0 on the negative terminal side, and at the positive terminal, label whatever voltage the battery is giving, which is 84 volts in our case. Now here comes the trick. Imagine you cut the circuit from here and gently unfold it into a straight line. So what will you observe? This will be point A with voltage 84, and this will be point E with voltage 0. Now after A, put all points from B to E like this, in a straight line. We have only this 1 ohm resistor between points A and B. So put it here like this. We have only this 15 ohm resistor between B and C. Then draw point D. We have this 9 ohm resistor between C and D. But we have an 8 ohm resistor between point B and D. So put it here. But that's not it. We have a 3 ohm resistor between point B and D. So put it here like this. Finally, we have a 4 ohm resistor between point D and E. This is how to put the circuit in a straight line. This visual trick helps you clearly see which resistors are in series and which are in parallel. Now at each step, replace any group of resistors which are either in series or in parallel with their equivalent resistance. We first see that these two resistors are in series between points B and D, and their equivalent resistance will be 15 plus 9 or 24 ohms. What do you see next? Yes, right. These three resistors are in parallel, and we can find the equivalent resistance using 1 over R equals 1 over 3 plus 1 over 8 plus 1 over 24. This gives R equals 2 ohms. So make the equivalent 2 ohm resistor between B and D. Now what can be said about these three resistors between A and E? Yes, right. They are in series. So their equivalent resistance will be 1 plus 2, or 4 or 7 ohms. Wow, nice! So what do you think will be the current that will flow through the battery now? Since we have the total voltage as 84 volts, and the total resistance as 7 ohms, the current will be 84 divided by 7, which is 12 amperes. Now, we will move in the reverse direction. Now, since all the three resistors between A and E are in series, this same 12 amperes will pass through each of them. What will be the voltage drop across this 1 ohm resistor? It will be 1 times 12 or 12 volts. So, if voltage at point A is 84 volts, then the voltage at point B is 84 minus 12, or 72 volts. Now, what will be the voltage drop across this 2 ohms resistor or across BD? It will be 2 times 12 or 24 volts. So if voltage at point B is 72 volts, then the voltage at point D is 72 minus 24 or 48 volts. This means the voltage drop across this 4 ohms resistor is 48 volts. Now, let us move one more step backward. Break this 2 ohm resistor into the original 3 resistors. The 24 ohm, 8 ohm, and 3 ohm resistors, all connected in parallel between points B and D. Now that we have the voltage drop across BD as 24 volts, the voltage drop across each of the 3 resistors is the same 24 volts. Now, let's find the current through each resistor. For the 24 ohm resistor, the current is 24 divided by 24, which is 1 ampere. For the 8 ohm resistor, the current is 24 divided by 8, which is 3 amperes, and for the 3 ohm resistor, the current is 24 divided by 3, which is 8 amperes. So the total current flowing from B to D is 1 plus 3 plus 8, which is 12 amperes. Exactly what we had earlier when we replaced them with the equivalent 2 ohm resistor. Finally, we can break this 24 ohm resistor back into the original 2 resistors, 15 ohms and 9 ohms, which were connected in series between points B and D through point C. Since they are in series, the same current of 1 amp flows through both. So finally, analyze them. The voltage drop across the 15 ohm resistor is 1 times 15, which is 15 volts. And the voltage drop across the 9 ohm resistor is 1 times 9, which is 9 volts. So starting from point B at 72 volts, the voltage at point C will be 72 minus 15, which is 57 volts. Then the voltage at point D will be 57 minus 9, which is 48 volts, same as before. Everything is consistent, and finally, we will rebuild the circuit back to its original form. Woohoo! This way now we have the voltage and current at each resistor in this original messy-looking circuit. And now we can solve any type of complex-looking circuit with 100% confidence. If you enjoyed this video, please don't forget to like, share, and subscribe to our channel. Also, you can support my channel by joining our community and becoming a member. So good.